We're going to look at hypothesis testing for normal distribution. This is a template we're going to use that's going to work for every question, not just this question. Let's first look back at the templates that we've done for the previous distribution. So binomial distribution, very similar, and also for zero correlation. So notice they all have a data box that's very similar, N, R, H0, H1, alpha. There's a diagram and there's a conclusion. They all follow this very similar pattern. So let's have a look at this example for normal distribution. Now, to help us and to stop us having to read the question time and time again, we're going to just make sure we highlight all the numbers in our question. And this is going to allow us to fill in the data box so that we don't have to keep rereading the question. A fruit juice company states that the amount of juice in a carton has a normal distribution with a standard deviation of 3. Right, we've seen that 3, we know it goes in this box here. And a mean of 60. Right, here's our mean, and our mean also goes up here. A trading inspector receives complaints about the company and decides to investigate. She takes a random sample of 16, so that's going to be our N, and finds that the mean amount of juice per carton is 59.1. So the result from her study, from her sample, is 59.1. Remember, if it's a lowercase x, it's a number. If it's an uppercase X, it stands for a sentence. So we put it on the x-axis, but it could stand for the mean amount per sample of juice in a carton. Using a 5% level of significance, so we're going to put 5 as our alpha, and stating your hypothesis clearly, state whether or not the company is overstating the mean amount of juice per carton. If the company is overstating, if we suspect they're overstating, it means we think actually the amount is less than. So because we're less than 60, we're in a one-tailed test. We're at the bottom of our tail. So we're not going to split our alpha in two the way we would if it was not equal to 60. That would be a two-tail. Okay, have a quick check. Have we completed everything here? Not quite. I can see there's something missing. So N is 16. Let's pop that in. Once it's complete, you can go on to the next step, which is the graph. So you're going to have a quick sketch of your graph. You know it's going to be normally distributed. We're plotting X bar. It's not X. So the difference between plotting X and X bar is the standard deviation is smaller. The variance is divided by 16. So here we can see there's a critical region either side. This is a generic template that works for when you need to work out the top tail or in a two-tail test, both of them. But for this, we're just focused on the lower tail, so we can ignore this critical region. So this critical region is going to be divided by the lower critical value. So we're not working out the upper critical value, we just want the lower critical value. What is that? Well, we know that the area of the lower critical value and below is going to be 0.05. So let's go on to our calculator. We're going to go into distributions, down to normal. Our mean is 60, so we're just pulling the data from here. And our standard deviation, remember, is going to be the square root. This is our variance, so we need to take the square root of that. Now make sure you're in your lower tail. We're going to change the area to 0.05. And it's telling us that that lower critical value is 58.8. So let's fill that in. Now we're ready to plot the sample mean X bar. So X bar is 59.1, mu is 60, this is 58.8. we must be in between these two values. So x bar must be in between since it's larger than 58.8 but smaller than 60. And now we can conclude. So we're going to say since x bar is greater than our lower critical value, and just make sure you put some values to this so it's clear what you've worked out. So this means we are in our acceptance region. It's greater than our lower critical value, which is our acceptance region, and thus we're going to accept H naught. And finally, you have to end with a sentence. So we're going to now say there is insufficient evidence at the 5% level of significance. Very important that you state this level of significance, and you can see why, because if the level of significance was 10, that might look like an area like this, and you can see now that H0 is within this critical region, which means that actually we would say we've got sufficient evidence. So the level of significance is very important to state. And now we're going to quote. So you can see I've put quotation marks there. And what you're going to do here is go back to the question and look for the word test. And it's something after the test. That's what you've got to find that you're going to quote. So test whether or not the company is overstating the mean amount of juice per carton. That's exactly what we're going to write to show that we understand the question. We're not just good at the maths, we also can put it into context. And that's it.